Hey everyone, welcome back for pretty much our last lesson of the year. This is going to be more on the Pythagorean Theorem, and this is going to be really heavy on the side of applications. So let's go ahead and get started. Like all of the other ones, this video is linked to the Punchline Bridge to Algebra assignment. This one is page 116, and that's where we're going to be taking these problems from. So let's have a look. All right, we have question 2 here with a triangle. One side is 17, the other side is 15. So just like we did last time, the most important side is a hypotenuse. Let's see where that is. I think you can all see where the right angle is, and look opposite to that, and you get to the 17. So C is 17. Just like before, the other two sides don't really matter, and in this case, since I don't have a vertical side, I'm going to choose to make that 15a, which of course leaves b as an unknown. So this is a lot like what we did with the previous assignment now. We have an a, a b, and a c, and we just need to use the Pythagorean theorem to solve for b. Okay, our clues are laid out for us. First thing, of course, is to write the Pythagorean theorem. Second step is to substitute those numbers. A is 15. B, you don't put a question mark, you just leave it B. And C, you go ahead and put a 17 there. Do some arithmetic. And by arithmetic, I mean you square everything. So 15 squared is 225. 17 squared is 229. That gives us 225 plus b squared equals 289. This is the algebra part of this whole thing. We're going to subtract 225 from both sides of the equal sign so that you can get b squared on the left side of the equal sign pretty much by itself. So b squared is equal to 64. To undo that square, you're going to take a square root. So the square root of b squared equals 64. Lastly, we get that b is equal to 8. 8 centimeters, because if you look at the diagram, everything here is in centimeters as well. And there's really no difference between one side and the other side as far as how do we measure them. So if one side is 15 centimeters, and the other side is going to be 8 centimeters as well. So looking at the diagram will often tell you what the units are going to be. Okay, here's a little bit more of a problem. There's a lot more to this one than the previous one. Now we get a parallelogram, and a parallelogram is a shape where opposite sides are parallel. I should say this is a quadrilateral where the opposite sides are parallel. So we have this bottom side broken up into one part of it is 9 and the other part is 10. And here's a height, h. This side of the parallelogram is 15. And we get two questions. Number one, what is the height? I assume that's h, and you should probably assume that's h as well. And then second part, find the area. And we'll look at that area formula when we get to it. I'm going to isolate that triangle from the shape. I'll go back and forth to it. Do you see where that triangle is? On the left side of the shape. There it is, isolated. And just like the previous problem, we're going to try to figure out which side it goes with A, B, and C, starting with the most important side of a right triangle, the hypotenuse, opposite the right angle. So this is pointing directly at the 15. So C is 15. That's better. C is 15. I have a side that's parallel to the bottom of the screen, so I'm going to let that be A. So A is 9. And that third side, I'm going to say B is the same thing as H. So when I put this together, A is 9, B is H, and C is 17. Let's see how that H is going to work in the Pythagorean theorem. So you'll notice that where I had an A, I put a 9. Where I had the B, I put an H. And where I had the C, I put a 15. Well, now that this says to me, instead of solving for a B, I'm going to be solving for H. So just like before, arithmetic, let's square everything. 9 squared is 81. 15 squared is 225. More algebra, subtract 81 from both sides. A little bit more arithmetic. If I subtract 81 from 225, I'm going to get 144. And then square rooting both sides, we get that H is 12. Okay, so B, the height, is 12. Just to remind you, this is a two-part problem. Not only are we meant to find the height, which we have done already, it's 12, we're also supposed to figure out the area. Okay, answering part A right on the left of the screen. The right of the screen, we're going to answer part B. And the area formula is the base of the parallelogram multiplied by the height of the parallelogram. Now we know the height is going to be 12. That's this vertical distance up here. That's 12. The base is going to be how far is it along the bottom, this horizontal section. And if you have a good sense of this, you know that this is just going to be 9 and 10 put together, or just 19. So if the base is 19 and the height is 12, that means the area is just 19 times 12. And of course, go ahead, ask Siri, ask Google, ask Alexa. 19 times 12 is 228, and the units here are square feet. Area is always a square unit, and feet, I think you see where all the feet are in this diagram. So 228 square feet for our area. Lastly, we'll get to this one, number 6. And we've got triangles drawn on 1 centimeter dot paper, and we're supposed to find the perimeter of each. Well, I'm not going to do each of them. I'm just going to do letter C, I think it is. It's a creepy squeak there, right? So let's isolate letter C. And 2 of those sides are really easy to measure. If the distance between 2 dots is 1 centimeter, then I think we get an idea just by seeing how many spaces there are from corner to corner. But of course, the most important part of a right triangle is the hypotenuse. So looking opposite from the right angle, I see C is something that we can't really measure because it doesn't fall squarely on the dots. No pun intended. So C is actually unknown. You could probably estimate it based on the number of dots, but we're not going to do that. We're going to use our mathematics to figure it out with some degree of accuracy at least. That leaves us with A is 3. Again, it doesn't really matter which one you call A and which one B, but I'm going to call that horizontal side A, and that's going to be 3. Now, of course, some of you might be looking and saying, hey, there's 4 dots there. Shouldn't A be 4? And distance is going to be how many spaces there are, not how many dots there are. So from this dot to this dot is 1 centimeter. From this dot to this dot is another centimeter. And then from this dot to this dot, that's another centimeter. So that's a total of 3 centimeters. Similarly, the vertical side, I'm going to call that B. That's going to be 5 centimeters. So now that we have all that information, we're ready to go with the Pythagorean Theorem. There's our Pythagorean Theorem. A squared plus B squared equals C squared. Substitute the numbers that we know. A is 3 and B is 5. C is unknown, so we're just going to leave it as C. Arithmetic, 3 times 3 is 9. 5 times 5 is 25. More arithmetic, 34 is the same thing as c squared. And then we're going to square root both sides to figure out our value of c. And using a calculator, or Siri, or Alexa, or Google, I don't know, however you want to compute this, c is about equal to 5.8. And I say it's about equal to 5.8 because it's not 5.8 exactly. I left off a whole bunch of decimal points at the end there. But as it turns out for this, you only need that 1/10th place decimal. So 5.8 is going to suffice. I'm going to keep that approximately equal sign every time I use 5.8 because that is an approximation and we should be using that. We know that c isn't exactly 5.8. Last part of this, or actually the only part that's the question, is the perimeter of this. So the perimeter would be all of the sides added together. We know what a and b are, and we know what c is after doing our algebra. So the perimeter is just 3 plus 5 plus 5.8. Actually, you'll see that this is approximately equal to 3 plus 5 plus 5.8 because 5.8 is an approximation. So when I use it in a calculation, that calculation becomes an approximation as well. All this said, the perimeter is about 13.8. That's the end of our work. You definitely have more to do. I only went through 3 questions, and as we saw, that previous question was a 3-part question, so you get to practice that a couple more times. And that's it for our Pythagorean Theorem mini chapter. I'll see you guys later, and actually have a good summer at this point, right? See you later.